On today's video, we're going to be talking all about TypeScript. Now, if you're a front-end developer and you use a lot of JavaScript, you may have heard of TypeScript but not actually have used it. So you might be wondering, why are people using this really boring looking tool? Well, three reasons. Firstly, it makes your code easier to write. Secondly, it will stop you making lots of bugs and mistakes. And thirdly, it makes your code safer for your users as well. So in today's video, we're going to talk all about TypeScript. So to talk about TypeScript, we first need to talk about JavaScript itself. JavaScript is a very dynamic language, which means that things can also go wrong because it's so flexible. So let's have a look at what we mean by this. Now, what I've just quickly done is I've got VS Code, I've got a test.js in here, and over here I've got a terminal. And if I just want to run this, I'll just run it through Node. If you haven't got Node installed, all you need to do is go to nodejs.org and download, and then you can run Node. So a quick example would be something like this. So if I do something like console log, and what I might want to do is see if someone is over 18. So they put their age in, something like, let's say they're 9 years old, and 9 is bigger than 18 or equal to 18, let's say. Now, what you would see if you save this, we want to run this by doing node, and then it's called test.js. What we'll see over here is false, which makes sense. But what we could also do is make these strings, so put some quotes around them. So let's put some quotes around this. Is 9 bigger than 18? Save, and I'm going to run again. And what we have now is true. So what we want to do here is basically make our code more strict. We want to make sure that the things we're putting in here are numbers and not strings, because we want this to be false. A 9-year-old is not bigger than 18, rather than true. Now, there's other reasons we might have in here as well. JavaScript is a very strange language. So for instance, if I have something like 9 plus 18, and I save and run this again, 9 plus 18 is 27. But if we make these strings, what happens here? 9 plus 18. Let's make one not a string. Save it and run. Well, there we get 9 plus 18, literally 918, which kind of makes sense because it's trying to turn this into a string. How about if we minus that? So let's minus that away. And what we should get now is -9. So JavaScript has a lot of weird things about it, as we can see. It sometimes does things that we don't really expect, especially when we don't really know what we're dealing with. For instance, strings minus a number. Now, there's other things that could go wrong when we just write code in general as well. So one thing that I had as a big mistake years ago when I was doing some freelance work is I had some code that looked like this. I was working on a booking website, and there was an object that we had, and it had a state. And that state was something like confirmed. The booking was confirmed. However, deep in my code, I was doing something like this. If booking.state is equal to completed. Now, confirmed is not completed, and I could not find this mistake. I didn't realize that this and this were not the same. In my head, I was looking for typos, and I was thinking, well, it does say confirmed, and this does say completed. There's no typos there, but they didn't match up. So what we want to do is basically make our code a little bit cleaner and also protect ourselves from all of these bugs. So this is where TypeScript comes in really handy. Now, to install TypeScript, we need to also install Node.js. So if you haven't done that, please do it already. And what we want to do is install it across our whole computer. I like to do it this way anyway. And if we scroll down on the TypeScript download page, we'll see it here, npm install-g TypeScript. So this we would do in our command line. We'd go back to our code and we can type it in up here. Now, of course, I've already installed it. And what I'm also going to use is TS node as well to basically run it as if it's like a JavaScript node thing. And to do this, we're going to do something very similar and install it down here. We're going to do it again globally. So npm install-g ts-node. So once we've done this, we can actually run our TypeScript. Now, back in my code base, what I've just done is deleted my old test.js, and I've created this new one called user.ts. So all of our TypeScript files always end in .ts. Now, what we're going to do is quickly kind of define a user system here. Now, when we generally define a user system in JavaScript, we do kind of something like this. So we'd say a constant is our first user. It's going to be Simon. Simon is one of my cats, and an object is going to be what this is. It's basically a single thing with some attributes on it. So for instance, Simon has a name of Simon, of course, And he also might have an email address. I'm going to treat this as a user rather than as a cat, simon@supy.com. And he also might have an age. We don't know how old he is, but let's say 11. Now, from when we did things in JavaScript, we might accidentally have put this as a string, something like this, which is kind of wrong because obviously when we want to compare things, such as like, is Simon over 18? This can sometimes lead to problems. So what we want to do here is basically define what is a user, or a cat in this instance, in our system. So to do this, we're going to make a definition of what is a user. So up here, I'm going to do something called an interface. Now, this is part of TypeScript itself. It says, what is the thing that we're trying to describe? And basically, we give it a name. Here, I'm going to give it a name of user. And what we do is define what this is. So using some curly brackets, we're going to define exactly what is a user. We know that name is a string, and this is part of TypeScript. We can also say underneath here that an email address is a string as well. And we can also say, well, age should be what? Well, we don't want this to be a string because we want to do maybe some comparison. It should be a number. And again, this is all built into TypeScript. And this is basically what we're trying to define here. But at the moment, this user has no connection to this Simon object that we have below. So to do this kind of connection, we're basically going to define and make it more strict and say Simon is definitely a user, not just an object, a random object, but he should be a user. So to do this, we're going to say const Simon, and then we're going to use a colon, and then the word user. Now, what this will do if you're using something like VS Code automatically is it knows it's a TypeScript file, and it knows that now there's a connection between these two things, and it's given me an error. It says age is wrong. And if I hover over it, it says age is the wrong type. String is not assignable to a number, which is correct. This should be a number. So there's a bug technically in my code right now because we've defined the wrong thing. So what I can do in here is say, this is wrong. This should be a number. So there's quickly an error that's been popped up here. Now, how would we run this? How would we actually write some stuff to do this check? So let's say we want to just pop out Simon's age at the end. So console log and then simon.age. Now, because we've installed ts node, what we can do instead of just node and then user.ts, because that's only trying to run JavaScript, is ts-node, if I can write it correctly, and then user.ts. And what this should pop out on the other end is 11, which kind of makes sense. This will never be a string because it will be wrong. Because if I do this as a string and save and try and run it again, we're going to get an error. Now, when we did this with JavaScript, this would not give us an error because JavaScript doesn't have these checks. So basically, TypeScript is a strict version of JavaScript. There's less kind of things that it can go wrong with or kind of pass through, basically. So we don't want errors. So that's a good thing. This is doing things correctly. So I'm just going to clear. And what we can start to do now is more things. So let's make another user. So constant Kylie is the other cat. Kylie should also be a user as well. And let's just quickly give Kylie a name, Kylie, and an email, kylie@supy.com, and an age as well of, again, we don't know how old she is, roughly about 6. Now, let's say that Kylie doesn't have an email address for some reason. Let's say we get rid of this email address and we save. What we'll see now is Kylie will error because technically it says property email is missing in type, which makes sense because a user should have all of these things. It should have name, email, and age. But what happens if we don't necessarily need email? Let's say it's a kind of optional one. What we can do is go back to our interface and say, well, email can be optional. And to do this, we're just going to put a question mark after email. So here, email could be blank, it could be empty, it might not even be there. But again, we have defined what a user is in our system here. Now, what we also might want to do is say, well, maybe Simon and Kylie are different types of user. Maybe Simon is just a regular user, but Kylie is a moderator. So let's say Kylie has a state of being a moderator. Now, of course, what this does is give us an error because there's nothing called state in our interface. But what we could do here is say state is a string. That is also going to give Simon an error because state isn't on Simon. Now, if we want to make that optional, we'd give it a question mark, but we might not want to make it optional. So I'm going to keep it as is and then just add a state on Simon of user. Now, the problem that I had in that bug that I used to have, which is like moderator or confirmed or completed, like we could accidentally put in mod, or we could have spelled moderator wrong, moderator, something like that, which is completely wrong. So how do we make this even more strict to say our state should be one of a few things, user, moderator, or admin? So to do this, what we can add is another thing in here. We want to define what this is. Now, an interface is basically an object. It's like a user with things on it. But this thing is going to be just a type. It's going to be either a user, a moderator, or an admin. So to do this, we're going to add a new thing called a type. And here, what we're going to call it is a user state, let's call it. User state is kind of what I've made it up as. Now, what can a user state be? Well, this is going to be equal to a few things. This is going to be equal to a few things like user or moderator or admin. To do this, we're going to say in quotes, user or type or moderator or admin. Now what I can do is use this user state thing that I just made up and add it in here instead of string. So instead of string, I can just say user state. And what this will do is it will flag up that this state is wrong. Moderator is not assignable to type user state. Did you mean moderator? So there's some kind of intelligence going on here in the background. And yes, I did. I did mean moderator. So just like my problem with JavaScript when I was doing confirmed and completed, this would have flagged it up and I would not have spent 2 days trying to figure out the mistake. So here I can just flag it up, moderator, and that will fix my errors. Now, again, what I can do here is because these are objects, I could do things like arrays. Like, how would I do an array of all the users? So here, what I could say is something like all users, and this is going to be a list of users. So I'd say user and then square brackets. And this is going to be equal to an array of Simon, comma, Kylie. Now I can't just put anything in here. So for instance, if I try to put in an orange or a car, this will also complain. So everything in this list has to be a user. It has to basically be defined as this thing. So there's a very kind of smart way to do this. Now, one other thing that's really, really useful is something like, well, what happens if I want to check and do functions? So let's say we have our function from before, something like const is over 18. Now in JavaScript, what you generally do is something like a function looking like this. So round brackets, arrow, curly brackets. Now what goes into the function is usually a general kind of user. So I'm going to say user. And what we would generally say is this is either true or false. But this isn't very defined because user at the moment could be anything. It could be is over 18 34? Well, no, it should be user, and then we're checking the user's age. It can't just be anything. But currently, this passes. This is like, yeah, cool, check. This could also return anything as well. Like we could be doing like an if statement here, and it could return a string. So what we want to do is do a little bit more checks. Instead, what I want to do is I want to check my user, the thing coming in, is of the type user. So here, I'm going to say colon user. And this complains. It says, well, 34 isn't the type of user. And if we hover, it says that. Argument of type number is not assignable to the parameter of type user. Well, what this should be is something like Simon. Is Simon over 18? Now, if we want to do a kind of true or false on this, we can also say what is going to come out the far side. So the user is here, but we could also have a colon after these round brackets and say, we want to return back either true or false, a Boolean. So I'm going to put in Boolean here. Now, what this will do is complain because technically in my code, it's not returning back a Boolean. So my function at the moment is wrong. So to fix this, I'm going to open up my curly brackets and say this should return either true or false, true or false. So that fixes it. Obviously, the code isn't correct. TypeScript has no context of what the code is, so we need to write this. But what we can do now is say, instead of true, we can say user dot. Notice when we do dot as well, it knows what's in here, age, email, name, and state, because it's defined. We can say age is over or equal to 18. So now what we can do is say console log this out. Console.log, and in brackets, is Simon over 18? Let's find out. ts-node, and then what we're going to do is user.ts. And what we get is Simon isn't over 18. He's 11. Is Kylie? Let's double check. This works. Again, if this was a string of 6, this would be true, because technically in an alphabetical order, 6 is above 18. But here what we've got is the right answer. Kylie is not over 18. She'd be a very old cat if that was true. So the last part is, how would we actually get the JavaScript out of our TypeScript? Because when we're using this in the browser, we still actually want to kind of use JavaScript rather than TypeScript. So what we can do is use something called TSC, basically the TypeScript compiler. Here what we're going to do is say TSC and then write the name of the file. So something like user.ts. And what this will do is convert our TypeScript into our user.js. Kind of looks the same, except there's less checks. Again, this is all going to run in the browser. So if we were to run this, user.js would be the file that we want. But if we write in TypeScript, we want to write it and then compile it into our final JavaScript file. So if we were to do this in the browser, we would still do script source and then user.js, not ts. So what do we want to do next? Well, what we want to do is maybe set this up as a project. Maybe what we want to do is say, well, I don't want my user TS and my user JS being all in the same folder. How would we go about doing this? Well, what we can do is just basically set up our project a little bit better. So I'm going to right click and add a new folder. I'm going to call this one src for source. This is where my source code lives. And I'm going to move my user.ts into my source folder. Let's move it. Yes, please. Now, if I run this again, I'll do, tsc and then source slash user.ts, and this will run, and then it'll keep it in that same folder. But I might want it to be outputted somewhere else. Now, this is where what we can use is something called tsconfig. Basically, I want to set some config up for my project in general. So here, I'm going to right click, add a new file, and this is going to be on the top level, tsconfig.json. Now, currently this isn't a JSON file. I'm just going to put in some curly brackets, and this has some settings that we can actually use. So if I go to the TypeScript homepage, there's a list of all the things we can actually do in our config. So let's just do something very quickly. Let's open up our JSON file and add in some compiler options, and let's add in a target. So target is basically what should we turn the JavaScript into, like what version of JavaScript. I'm going to use something called ES6, which is fairly new JavaScript, and I want this to be output somewhere, out dir, and this is going to be out into a folder called JS, let's call it. So let's save that. Let's remove our user.js because this is in the wrong place. Let's remove this other one, which is in source. I don't need that as well. And what I can do now is, because we've got this tsconfig.js, what I can do is just run the tsc, and this will run across my whole folder. Now I've got this JS folder with user.js in here. Now, what we might want to do is make sure that when we do any updates, such as Simon is now a year older at 12, but on my JS, he's still 11, I might just want to watch all of these files. So to do this, I'm just going to do tsc --watch. And what this will do is it will set something up in our command line to basically listen out for any updates. So if we change him to, let's say Kylie's now 7, and when I run it and save, this will update and there's no errors. And we can see in our final JavaScript 12 and 7 there. So this is basically how we can actually set up a TypeScript project. Basically, it's very, very simple, but it protects our code. It makes our code easier to read because we can see exactly what user is. We have some smart things in here as well, because things like VS Code implement this. It means our code has less errors as well. And it basically makes our code a lot safer for our users. If someone's putting in a string, we know it's wrong. We need to actually fix these things. So this is TypeScript in a nutshell. So let me know what you think. Is TypeScript something you'd want to add to your toolset? Let me know in the comments below. And of course, if there is anything you'd like me to cover, let me know in the comments below. Give this video a like, give it a share, do all the kind of usual things, and I hope to see you in another video very soon.